Hello, testing. Hello, Snowy Kale, how you doing? Welcome to the stream. Hello, good morning, or afternoon, or evening, wherever you are. We're doing more Microsoft Leetcode questions today. Woo! Let me get to the Microsoft page for Leetcode. Why is Edge not capturing? Well, bam. Okay, there we go. But yeah, hello. How are you guys doing? Last time we did Meeting Rooms 2, longest common prefix, merge strings alternately. Yeah, we did those 3 last time. I don't think we did next permutation, so I'm going to try that. Leetcode 31. Snowy Kale says, hello, how are you? I'm doing good. How are you? I got nice sleep yesterday. Leetcode 31. I got up and I'm eating nutty bread from Safeway. Let's change this to Java. Next permutation. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. You mean of linear order? For example, for r equals 1, 2, 3, the following are all the permutations of r 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1. Okay, 3, 1, 2, 3, 2, 1. I see. Okay. Take the first one, swap the two last ones. Take the second one, swap the remaining. Take the third one, swap the remaining. Snowy Cow says, I'm good, played a few games and chilled. Oh cool, what games do you play? Speaking of games, I recently discovered Pokemon Sleep. It allows you to, I don't know, sort of catch Pokemon while you sleep. It's pretty goofy. Ironically, I haven't been doing very well in that game. It thinks I only get 6.5 hours of sleep a day. Wait, that game is really goofy. You actually put it on your bed while it sleeps, and I think it records you and detects your bed mattress movement when you sleep. So it only counts, it only thinks you're starting to sleep if you stop moving around a lot. So I lose 30 minutes a day. Yeah, Snowy Cow says, for now, mainly Honkai Star Rail. Ooh, Stardew, because I don't have much time with work going on. Ooh, sounds fun. Yeah, Pokemon Sleep. I take like 30 minutes to fall asleep, so it thinks I only get 6.5 hours a day. Yeah, apparently the more you sleep, the higher quality the Pokemon you wake up to. Do you get a Pokemon or something when you wake up? Oh, it's more like the game design is like you're sleeping next to a Snorlax, right? A Snorlax has the power to attract other sleeping Pokemon while it's asleep. So you can make its, I don't know, attraction power stronger by getting lots of sleep and increasing your sleep quality. And when you wake up, if your sleep quality is good, you have a higher chance of getting better Pokemon. So for example, I did the worst on the first day. I only got like 6.2 hours of sleep or something, and I got some Caterpies, Metapods. Second day I did better, so I got some Ghastlies. Yeah. Snowy Cow says, oh, that sounds cool. It makes me want to download it. Yeah, it's a really goofy game. Yeah, I have no idea how it tracks your sleep quality. I think it records you and it tracks your mattress movement. So it says that you can't put on a hard surface, or also think you're like Yeah, I don't know. It needs some sort of mattress movement. But yeah, I really want to try seeing what happens if I get like 7 hours of sleep. It hasn't counted me as 7 hours of sleep over yet. Yeah. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows in its sorted container. That hurts my brain just to read that. If such arrangement is not possible, the array must be arranged as the lowest possible order, i.e. sorted in ascending order. So 1, 2, 3 becomes 1, 3, 2. 2, 3, 1 becomes 3, 1, 2. While the next permutation of R 3, 2, 1 is 1, 2, 3, because 3, 2, 1 does not have a lexicographical larger arrangement. Oh my goodness, this sounds hard. Snowy says, do you play any games outside of that? Oh, not recently because I'm job hunting, right? I don't have much time for gaming, but I have tried Once Human. I have played Sky Children of the Light a lot. There was a time where I played Phasmophobia a lot, but yeah, I don't play much games right now. Currently grinding Leetcode and applying for jobs. The replacement must be in place and use only constant extra memory. What? So 1, 2, 3. Okay, you swap the last two. 3, 2, 1. One, two, three. Oh my goodness. This problem sounds hard. What the heck? And it has to work for any length of integers. Snowy says, oh, understandable. I hope job hunting is going well, though. Oh, thank you. It's going okay. I fail some. I win some. I feel like I'm getting... I'm doing better and better on the Leetcoding interviews, at least. Yeah, so that's a win. Array 2 pointers. Oh, that's a hint. Array 2 pointers. But what do I do with that information? Okay, so let's start with the base case. I mean, not base case, a simple case. So I have 1 here, it's completely sorted, so I'm like, okay. Swap the first 2, swap the last 2. What happens if I have like 1, 2, 3, 4 though? Nums.length can be up to 100. Huh. Next permutation of array is the next lexicographically greater permutation. What does that mean? More formally, if all the permutations of the array are sorted in one container according to their lexicographical. Hold on. Does this mean like if I combine all of them into a number that they're going to be greater? Alphabetical order? Okay. Okay. Alphabetical order. So for this one, what's the next one that's just slightly more than it? 2, 4, 3, I guess? Oh, this is hard. 1, 2, 4, 3. What comes after this? 1, 2, 1, 4, 2, 3. Dang, bro. I can't even do this manually. What happens after this? 1, 1, 4, 3, 2. I think I need some hints on this one. This one is pretty hard. Do they not have hints for this? It says array and 2 pointers. One, 2, 3. 3, 2, 1 becomes 1, 2, 3. How do we know that this becomes 1, 2, 3? This is like the biggest number we can form from this, right? So if all the numbers are ascending and descending, oh wait, that's a clue. Maybe we have to look at the relationship, like what is ascending and what is descending. So like, assuming that all the elements are in ascending order, what's the second biggest thing or second smallest thing I can make? I can take the biggest number and put it into the next digit place, right? Okay. That's something, okay. So if all of them are in descending order, then I reverse them completely. We are onto something, boys. 1, 2, 3, 4. Yeah, okay. 1, 2, 3, 4. How do I make the next smallest one? Place the biggest digit in the next one. 1, 2, 4, 3. How do I make this the smallest one then? When it's not ascending, I swap it. Is that the pattern? Oh, I feel like we're onto something. 1, 4. That doesn't work here though. Do I just keep swapping the ones that are in descending order? 1, 2, 4, 4, 3. I'm so confused. You know what? I'm gonna take a peek at the solutions. Edge. Next permutation. This one is very muzakashi. Brute force. We will find every possible permutation of list formed by the elements. Okay. Okay, single pass approach. First, we observe that for any given sequence that is in descending order, no longer next larger permutation is possible. For example, no next permutation is possible for the following array. Yeah, that makes sense. So then you reverse everything. We need to find the first pair of 2 successive numbers from the right which satisfy a1 greater than ai minus 1. ai, so the bigger number is greater than the smaller. Okay, the first one that's in ascending order. ai and ai minus 1. Okay, so they're in ascending order. Snowy Kale, me, You. Oh, what are those emojis? Student and teacher, huh? Kind of funny. Okay, so we find the first pair that are in ascending order, huh? Now, no rearrangements to the right of ai minus 1 can create a larger permutation. What the frick does that mean? Since that subarray consists of numbers in descending order. Oh, I see. Right. Find the first one in ascending order. Snowy says, may I ask what got you into coding? Oh, that's a good question. I actually really liked animation in high school. I used Autodesk Maya. I made Pixar-style animations. And then I joined a game jam with some friends. We used Unity, and I found out that you can incorporate like Maya animations into games and code stuff with it. And I was like, oh, okay. That's pretty interesting. So I learned how to make games in Unity and C#. And I think that's how it got started. I actually would have gone to college for computer animation, except my parents really wanted me to do CS. But that's where my drive for it comes from. Yeah. Yeah. More recently, I haven't used Unity in a long time, but I have been learning Unreal Engine to make some more animations. Yeah, no problem. Thanks for asking. Let's see. Since the subarray consists of numbers in descending order. Okay, thus we need to rearrange numbers to the right of ai minus 1, including itself. What kind of rearrangement will produce the next larger number? We want to create the permutation just larger than the current one. Therefore, we need to replace the number ai minus 1 with the number which is just larger than itself. Among the numbers lying to its right section, say aj. So what about the case with 1, 2, 3, 4? The first number in ascending order from the right is this one. We want to replace the number ai minus 1 with the number which is just larger than itself, which is 4. 1, 2, 4, 3. I see. Find the first ascending pair from the right. 2, 4. Replace it with the number that's just larger with it on the right. So 1, 3, 4, 2. Yeah, okay, I see it. So first ascending pair on right. Replace the left of this pair with largest, just largest on right. Okay. Swap the numbers. Oh wait, we now have the correct number at index I minus 1, but still the current permutation isn't the permutation that we are looking for. Oh, okay. We need the smallest permutation that can be formed by using the numbers only to the right of I minus 1. Therefore, we need to place those numbers in ascending order to get their smallest permutation. I see. So next to ai minus 1, we need to place those numbers in ascending order. So 3, 4, that's not a problem. There's only one digit after here. 2, 4, you swap 3 and 2. I see. So this becomes 1, 3, 2, 4. Naruhodo. That makes a lot of sense, actually. Sort the right side in ascending order to get the next smallest possible one. I see, I see. That actually makes a lot of sense. Okay. Replace me with the number just bigger than me. The minimum number just bigger than me on my right side. So you increment the number as minimally as possible, and then you sort the rest in ascending order to make that chunk as small as possible. Okay. I think that makes sense. But recall that while scanning the numbers from the right, we simply kept decrementing the index until we found the pair. We simply need to reverse numbers following AI minus 1 to get the next lexicographic permutation. So the side to the right is always in reverse order. Why is that the case though? We simply kept decrementing the index until we found the pair. Oh. I see. Because we were trying to find the first ascending pair, then the rest are guaranteed to be decreasing in descending order. I see, just reverse. Cause I see. Right, we found the first pair that was ascending, so the rest are guaranteed to be descending. Oh my god, how do you even think of this? And switching the two numbers that are like really close to each other won't change the ordering, right? I replaced the number that's just bigger than me. Okay, that shouldn't change the relative order. Okay, so this is the animation. They're looking for the first ascending pair, which is 4, 7, I guess. Swap 7 for the digit that's just bigger than it. Oh wait, it's swapping 4. So 4, 7 is the first ascending pair. Swap 4 with a digit that's just bigger than it. And reverse the rest. Four, 7, swap 4 with 5, and then reverse the rest. Okay. Okay, so that's the solution they give us. Okay, I is equal to nums.length minus 2. Okay, I guess they're first checking for pairs here. While I is greater than 0 and nums I plus 1 is less than nums I. So while it's in decreasing order, you decrease your index. If I is greater than 0, int j is equal to nums.length minus 1. while j is less than nums I, j minus minus. Wait, you're swapping it with the... What are they doing here? While j is less than nums I. Wait, so you're looking for the element that's just bigger than I? With the number which is just larger than itself amongst the numbers lying to the right. Okay, so it's in descending order, right? I see, I see. You find the first number that's just bigger than you. So you're like, when you get to 5, you're like, okay, everything has to be less than 5 here. I see, I see. While nums j is less than or equal to nums I, j minus minus. Oh, they're starting the search from the most right. Okay, so yeah, so the first number that's bigger than it. And then you swap I and j. Swap is easy, okay? And then you reverse nums starting from I plus 1. How do you do this? Swap. Okay. I think I have a general idea how to do this now. Let me just copy this. Woohoo. Okay, so search for first ascending pair. Int I, let's start the index at nums.length minus, let's do minus 2. Let's do a for loop for, so while it's in descending order, we keep incrementing. So while nums I is greater than nums I plus 1, then I minus minus. We also need to make sure that I is in bounds, so I is greater than or equal to 0. There's not really any need to put anything in the for loop, do we? Should we do a sanity check right here? Let's just print out what I is. System.out.println I plus I. So it's not going to be right, but I just want to check that we got the right I. Okay. 0, 1, 2, 2, 1. Yeah, that's correct. That's the first ascending pair. Case 2, -1. All right. One, 5. Okay, that's right. Huh, what do we do in the case that Okay, replace left with the number that's just largest on the right. Find number just larger than I. So I guess it's useful to remember that everything is guaranteed to be in descending order. Everything already in descending order. So we can just search from the end to the front. And the first number that's bigger, yeah. Okay. Int, let's call this j is equal to nums.length minus 1 for j is, while j is less than or equal to nums j minus minus. So we should arrive on the number that's just bigger than nums j is greater than 0 and okay. Let's do another sanity check too. Let's print out what j we got. Run that thing. Right. If I is -1 here, we're kind of screwed, huh? I see. I was checking on the solutions again. I guess we only check for j if I is greater than or equal to 0. If I is greater than or equal to 0, okay, run this thing. I is 1, j is 0. Wait, is that right? The number just bigger than 1, the number just bigger than 2. While j is equal to nums.length minus 1, so it's automatically 2. While j is greater than 0 and j is less than or equal to nums oh, I know. Nums j, we have to compare the actual value. Yeah, there we go. I is 1, we will swap it with 3, which is at 2. -1, 2. 1 swaps with 5. Okay. We Gucci here. Okay, and then we need to swap I and j. Swap I and j. We will do a helper function for this. Private void swap, where we will take the same nums and int I, int j. Okay. Int, let's store I in a temporary variable. Int I is equal to the value of index I and nums I is equal to nums j, swap the elements, and then nums j is equal to temp I. Okay, that should be it. Swap nums I j. We swap the numbers here. I should also print out what the current array is. One more sanity check. Well, I'm going to do a lot of sanity checks here. Arrays dot toString is how you print out arrays. And then nums equals O. The result of swapping 1, 2 is still 2, 3. That's not right. Oh, I see what happened. IJ. I inputted the wrong variables. Oh look, case 1 and 3 passed. We haven't reversed anything yet though. So yes, we swapped the last two. We swapped the last two. Alright, fantastic. And then next up, we just swap everything in descending order to the left. Okay. We'll probably make a helper function called reverse. We'll put in nums and the element to start reversing on. We'll call it I plus 1. Yeah. Oh, you know what? That actually makes a lot of sense. If I is like -1 here, we'll start reversing on 0. Oh, very cool. That makes a lot of sense. Private reverse. We put in int nums and int I. Huh, this is actually really cool. If I is -1, then we reverse everything. Okay. Yeah, that's really cool. Do we just do 2 pointers and then keep swapping it? Start is equal to I, int end is equal to nums dot length -1. While start is less than end, then you keep swapping them. Swap start, comma, end. And then start ++, end -2. Update the pointers. Oh, so this is why they call it two-pointer problems, huh? The reversing part is 2 pointers. Let me double check the solution again. I think I got it. Run that thing. Private void reverse. Swap. Oh, we input nums here. Let's go. I think we got it, boys. All the test cases pass. Uh-oh. Okay, 511 supposed to be 115. Wait, don't celebrate too early, Snowy. We're almost there though. 231 out of 266. Okay, so apparently we thought that the first ascending thing is 51. That's not right though. That's the same number. I think I know where it's coming from. Greater than or equal to, right? If nums I is great, if the left number is greater than or equal to nums I plus 1, then we continue. Let's use this test case. Got you, okay. It was just a greater than or equal sign, right? Let's go! We got it, boys. Okay, now you can celebrate, Snowy. Woo! Let's delete all the useless print statements that's clogging up all the latency. Thank you, Snowy. Dude, we beat it 100%. Wow, dude. That's pretty sick. Deleting print statements really helps, huh? Oh. This is a hard problem. I think I need to record this problem down and make a note to do it during a review session. Which one was this? Leetcode 31, medium. Man, I swear, this is a really difficult medium problem. I'm gonna start this one actually. I had no clue how to do this one before I was looking at some solutions. Let me hydrate. Okay, what's next? Let's do more Microsoft questions. Next permutation, group anagrams. Have we done this one before? Oh, in case you're wondering, this account, this premium account, is my brother's account, so just because it says he did it doesn't mean I did it. Group anagrams. Given an array of strings, okay, group the anagrams together. What's an anagram? An anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. Okay, basically a rearrangement. Return the anagrams together. Wait, group the anagrams together. You can return the answers in any order. Okay, bat. Okay. 8, eat, tea. I see. I don't think I've done this one before. Leetcode 49. Leetcode 49. Ooh. Today's problems are all really hard. Yeah, I have not done this before. Okay, group the anagrams together. Okay, I have some idea of how to do this. I think to tell if they're anagrams, we just need to sort the strings, no? Do we sort the strings? In alphabetical order, maybe? Or is that too long? So nat would sort to ANT. Everything would sort to ANT here. But yeah, we can do like a hash map where the key is the string sorted in alphabetical order. Yeah. And then the value of the hash map is a list, a string list of all the anagrams so far. So for each word, we would sort it. Yeah. And then we would search the hash map for if the sorted key exists, and then we would add the anagram to the string list. Okay, I think that's the solution I'm going with. Yeah. Cool. Let's go. Hash map, string, and then a list of string. Let's do hash map. I don't know what else to name this. Is equal to new hash map. Okay, and then for every single string, for every string s and strs, we need to reverse it. String, no, not reverse it, sort it. String sorted is equal to, we'll probably do a helper function for this. Letter sort s. And then add it to the value map. No, the list value in the hash map. List string anagram list is equal to hash map dot get or default. Let's call this the sorted key for better variable naming. And then by default, we'll return a new list. New linked list, I guess. I heard linked lists are better for appending. You add the string into anagram list, add s, and then you put the list back in just in case it wasn't there originally. So hashmap dot put the sorted key and the anagram list. And then you return everything, right? Yeah. list of string result is equal to new linked list. And then you just add everything in. Or I guess every string key in the hash map. Result.add hashmap.get key. Yeah, I think that should be it. Okay, what's the best way in Java to sort a string? Java sort string letters. convert your string to char and then arrays.sort. I see, I see. You know what? I'll just steal this code. It's just 3 lines of code. That's pretty sick. Private letter sort. This returns a string. It takes in a string to string s. Okay, the string to a character array is equal to s dot to character array. You sort the character array and then sorted string is equal to new string character array. Return the sorted string. Okay. For sanity testing, I will print out the word I'm currently using, system.out.println s is equal to s. And then I'll print out what the sorted version is too, just for peace of mind. Sorted key. Sorted key. Run that thing. Probably not going to work, but we'll get some useful information. Oh, got key set. That's how we get the keys to a map. No return statement. Return result. I forgot the return statement. Wait, it passed? Wait. I didn't think this would pass. This was supposed to be just a sanity check. Why is it passing? Okay, E goes to AT. T goes to AT. I mean, yeah. What happens if we submit this? Dang! We did it, boys. It works. Wow. I didn't think I would get it on my first try. Hey, thanks, Snowy. Snowy is celebrating. And if we delete the print statements, we go to 65%. Let's go. I'll take it. I'll take the W. Yeah. I'm curious what the official solution is. Oh, hey, Dragon. Hello. Categorized by sorted string. That's what I did. Categorized by count. This is k log k time. K is the maximum length of string. Yeah, n log n time, that makes sense. They did it in n time? How? Only if their character counts are the same. Oh, I see. That's a good way of doing it. So the key of the map is an array consisting of the counts of all 26 letters of the alphabet. Wait, you can't store a list. Well, you can though. Okay, so in Java, the representation of the count will be a string delimited with hashed characters. Oh, that's complicated. But yeah, I see where they're going with this. This is definitely... Yeah, I see where they're going. You know what? I will take my W though. I think I'll still record this problem down for review. What was this one? 49. But yeah, hey Dragon, hello, hello. How are you doing today? Yeah, this solution is pretty clever. Dragon says, good. Yay. Oh my god, there's so much people here. Hi Brime, hi Teji. Call me CJ. Why is everyone just here? What's up guys? Hi Brime, hi Teji. I was not gaming raid. It's playing games like a real gamer. Welcome raiders. Wow, thanks for raiding Teji. Oh yeah, if you guys don't know Teji, he plays the guitar. And he's also making a game that I'm helping a little to program too. Heyo, heyo. Okay, hey guys. We're trying Microsoft Leetcode questions today. It's relatively not pain so far. Merge intervals, we did that. Climbing stairs. Add two numbers. Reverse integer. You know what? I think I'm gonna try climbing stairs and then call it a day. Leetcode 70, climbing stairs. Leetcode 70, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can climb either 1 or 2 steps, and how many distinct ways can you climb to this top? Okay, this is like recursion, right? What's my base case? If I'm already at the top, let's see, if n is 2, 1 step plus 1 step, 2 steps. So if I'm on the 0th step, wait, if I'm on the 1st step, then I'm already on the top, right? Is my base case 0? 2 steps minus 2. Sure, let's do base case is 0. If n is equal to 0, return 1, because that's one way to reach the top. Else, you return the ways to climb the stairs if climb stairs n minus 1, you take 1 step, plus climb stairs n minus 2 if you take 2 steps, I guess. And you return this. Is that how you do it? I'm so paranoid. Is that actually the only base case we need? Oh, I know. What if we're out of bounds? If n is less than 0, then we return 0. Return 0. Run that thing. Oh, frick. Let me guess, time limit exceeded, right? Time limit exceeded? Yeah, time limit exceeded. No, we need a faster solution. It's okay, guys, I know what to do. We need to cache our solution somehow. Okay, we can use a int array for this, right? So here we pass in a int cache with all of our previous solutions. We can do int cache is equal to new int array with the size of m plus 1. So the indices range from 0 to n. And then we call climb stairs with n. Is it n? Sure, n. Yeah, it's the same problem, right? So n. And then we pass in our empty cache. I think we'll instantiate everything to -1 for now to represent no solution. Arrays.fill cache -1. Okay, so now we have a new base case here. If there's a cache hit, if cache n is not equal to -1, then you return the cache value. Return cache n. Okay. And then we need to cache all of our previous results too, so int result is equal to that, and then before we return it, we cache it. Cache n is equal to result, return result. Let's use this test case. How many compilation errors do we have? Return result. I forgot semicolon. I forgot return statement. Uh-oh, that's not a good sign. Time limit exceeded. For 44. Is it not getting any cache hits? Cache n is equal to result If cache n is not equal to -1, wait, why? Why is it not getting the cache hit? N equals 44. Uh-oh, am I just royally screwed here? Cache n is equal to result. If cache n is not equal to -1, then return cache. Do we really not have any cache hits? System.out println. Cache hit. Snowy says, I gotta head to bed now. Thank you for the stream and good luck with the problems. Yeah, sweet dreams, Snowy. Good night. N-1, N-2. Huh. I actually have no cache hits. Cache. Oh. I know what's wrong. We don't call the cache form of climb stairs in the recursive call. Cache. Cache. Oh my goodness. There we go, now it passes. Submit that thing. Let's go. All right. All right, it said it was an easy problem, but it still took us some time. Part of the reason why I chose an easy problem too is that my phone says it's running out of battery. We won't be able to stream much longer today. Leetcode edge. Yeah, so I just did the first easy problem I saw in this list. We did merge intervals, right? We did climbing stairs. We just did group anagrams. Find medium from data stream. Next time we'll probably work on reverse integer. Okay. Very cool. Alright guys, we did 3 problems today. And it all went pretty okay. Yeah. I think that's it for today's stream. We did 2 medium problems, 1 regular problem, easy mode. Alright, thanks everyone for coming. Thanks Snowy for being here the entire way. I don't know. I can't see my viewer count. I don't have access to that now. Thanks Kami CJ, thanks Teji, thanks Brime, thanks Mono Acoustic. Hope you enjoyed the stream, the short while that you were here. See you guys tomorrow. Oh wait, I'm not here tomorrow. See you guys Monday. See ya, bye. Have a good day.